Um, Hi everyone. So today we're going to talk about the exponential functions. First, let's look at the format of the exponential functions. So it is always like this form. And it's even more. First is b must be greater than 0. So b cannot be a negative number and b cannot be 1. You know if b equal to 1, f of x equal to 1 to x power. Then no matter what is x, this is always equal to what? 1, am I right? So that can be very simple. So that's the reason we say b cannot be 1. That's the reason. B cannot be negative either, because that would make things more complicated. So we only consider b positive, not 1. Of course, x can be any the real numbers. The b is a constant. We call b is what? The base. I can give example. I say f of x equal to half. That is positive to x power. This is exponential function, right? I say f of x can be 3 to the x power. Exponential function. Right? We can discuss this type of exponential functions. The first question usually we're going to give you is ask you to evaluate an exponential function. For example, here, f of x equal to the 2 to the x power. Then evaluate when x equal to 3, when x equal to negative 2. What's the value of the function? So f of x equal to 2 to the x power. So when x equal to 3, then we say f of 3 equal to 2 to the third power. So this actually equal to what? 8, right? So f of negative 2, so equal to 2 to the negative 2 power, right? When x equal to negative 2, right? So this way we say it is equal to, when you have a negative exponent, what you're going to do is flip the base. The base is 2, you flip it, become half. And then at the same time, you can convert a negative exponent to positive exponent. Is that simple? So this give you half square is 1 square over 2 square. 2 square is what? 4. We can change. You say f of negative 3. That's the same thing. So 2 to the negative 3 power. So equal to flip it. So this way the exponent will become what? A positive number. So this is equal to 1 to the third power and 2 to the third power. So this gives you 1 over 8. So that's how we deal with the negative exponent. For the negative exponent, it's a graph. It's like this. So here's the example. So first of all, for any exponential function, it must go through 0, 1. This point, you can see it is here. Okay, there are two functions here, two graphs here. One is blue, one is red. Okay, so must go through this point. Why? Because f of x equal to b to the x power. When x equal to 0, then this equal to b to 0 power. No matter what is their b, because b is positive, not equal to 1, am I right? Then in that range, no matter what is their b to 0 power always equal to 1. So that's the reason 0, 1 must be here, must be on the graph, no matter what's your graph. So when your b greater than 1, remember, b is positive, cannot be 1. So b either greater than 1 or b between 0 and 1. That's what b can be. When b greater than 1, so the graph will be like this red part. If your b less than 1, greater than 0, then the graph will be like this. Okay. When greater than 1, here's the graph. When between 0 and 1, here's the graph. So this is what? Is a growth, the first one. And for this is what? Is decay, is going down. And you see, what determines the graph is the base. For the blue one is what? Is half. The base is half. For the red one, the base is 2. you see they are symmetrical about the y-axis, right? One is goes up, the other one is going down. It depends on B's value. Because here B is what? A quarter. Then between 0 and 1. So the graph must be what? Going down, decay. So it's like this. All right. There's another one is symmetrical on this side. Symmetrical. This must be what? 4 to the x power. All right. Because this is what? A quarter is what? 1/4 to x power. So they must be symmetrical. Isn't that interesting? So B is 4, B that means greater than 1. So you can see this is what? Goes up, right? So B is what? Less than 1, greater than 0, must be going down. The exponential function is graph. Here B is what? 3/4, right? So must be decay because less than 1. So the graph would be roughly like this way. Now B is 3, so the graph will be growth. It will be like this one, right? Going up. There's a natural exponential function. So we're using a constant, which is E. E is a constant. It's like pi, unlimited, non-repeating decimal. It's 2 point something. That's greater than 1. So the graph is which one? Is this green one. So that's the one. The natural exponential function. So I also draw this 2.5 here. This is half, this is 2. They are symmetrical. Okay. You can see this is what? This is 2. This is half. And this green one is 2.7 something. So the base is bigger, you're getting closer to what? To y-axis. But no matter what, this linear function must go through the 0, 1 point. So which means so if this is 3 to x power, then this one must be bigger than 3, maybe 4 to the x power. But how about 2 to x power? So this is 2 to the x power. So that's the relationship. Okay. Of course, it's easy for us to evaluate, right? So 2 to the second power is 4, right? Because you see x equals 2. When x equals 3, 2 to the third power is 8. When x equal to -4, then we say we flip it and then to the 4th power, which is 1/16. You do not have to have the parentheses. You know that if you feel confused, email me. I'm going to help you, okay? This is application. It's like modeling. We're going to talk more about this in compound interest. Dr. Shukla is in charge of that module. You will see that later in financial mathematics, okay? But here is just explanation directly how to use this formula to calculate the future value. So we say the accumulated balance, which is A, that means the total the money you have in the account, equal to your principal, which is $1,000. And then 1 is never changed, it's going to be constant. R is the rate. So here's the 3%, am I right? 3%. Divide by N. N means what? The times, number of times you compound every year. So here is yearly, so daily, so whole year, then you're going to have 360 days. We explain this why 360, not 365, because we use the standard day in industrial. So we call it 360. And then times, what is n? N is the how many times, right? 360 times per year times t. T is what? How many years? 3 years. You have the graphing calculator to input the whole thing to be able to calculate these results. Okay, so here, as I said, we're gonna attach a new video in the website. You on the top website is the main page, right? And they have resources as a team, right? You click on the resources button on the very top, you will see the materials. You can see this material that how you use the graphing calculator to calculate this result. Here, basically, I just show you the exponential function can be used to calculate the future value or accumulated balance for compound interest. Again, if you have any question, you can always feel free to contact me. Thank you.